In these slides, we want to discuss what happens if you go to a region of space that's completely empty. So take away the Earth, take away any gravitational effects, take away any force acting on this mass altogether, and just have an external agent, your hand, touching this mass, holding this mass, starting at rest, and then moving it along this path, and then leaving it over here at rest. In this situation, what will the work due to the external agent be to go from point 1 to point 2? Well, during the initial part of the motion, the mass has to gain speed, so there must be a force acting to the right. And since there's a force acting to the right, then there's work, because F dot delta R is a positive number and it's positive work. Now, the work also, as you go to the right, there's still positive work being done. But once you get to some point along the path, you can just let go. You don't have to even touch the mass at all. The mass will just keep on moving with its speed as it moves. And then, but the problem is, we said we wanted to make it reach point 2 at rest. So now if you want the mass to stop, you need to apply a force in the opposite direction by the external agent. That's going to slow it down. And now the force dotted into the element of length is that the dot product is negative because there's a 180 degrees angle between them. So you get negative work until it stops in the end. So some parts of the path you have positive work, sometimes parts of the path you have negative work. The total work is 0. How else could you see that the total work should be 0? You could see this by applying the work kinetic energy theorem. The work kinetic energy theorem says that the work due to all the forces, in this case the only force is the external force, the external agent, equals to the change in kinetic energy. As long as the initial kinetic energy and the final kinetic energy are the same, that means the difference in kinetic energy is 0 and the total work done by the external agent is 0.